So we've had this in your biochem. I think you already have this also in your kinetics right now. You've reviewed some of these topics. We've already discussed this in your general chemistry. So what we will do is just scan through the different details, and then I'll just give activity sa lab. Okay, so practice na naman na. So I think it works a lot for all of you. Those concept into which butang ko formula, and then there's answer, diba? On the last area or on the paper, you will just have to look for a solution on how to derive to that answer, diba? So I think it's quite effective since you are the one making a way on how to do things, diba? So I guess everyone's here. Let's see the attendance. Bugtaw na kamo da guys. Diba no ka aga gisang 8 o'clock always. So iba nyo nga classmates di na 22 attendees. Please chat some of them so that we won't be wasting some of our time. So kamusta ang life? So I think you've seen your grades for the midterm. And this class, there's no really problem. Aside from medyo may jutay lang man gid, medyo nubo-nubo, but somehow passed gyapon, and almost everyone are quite really smart, diba? If I could really compliment you with all the things with midterm and prelim. So I guess it's a good assessment because it means that you get the lesson. Or somehow, maybe you've memorized some of the concepts before, but it's really good that you are quite good into applying it, especially in calculation. So I hope that this will continue. And damo ta segue pero kay 24 attendees pa lang. Okay, so we overall 34 ka makabilag sa akong klase. Okay, so bugtaw na kamo da. Hi, hello mga kamo da be. Raise hands da be, okay na kamo da. So let's start na lang. Okay, very good. Me, I can sa ang glycoside because you're really active. Okay, so some of the concepts here, I think I've just gotten, okay, I've got this info or notes also from my biochem class, because since this is still a recycled topic from every other class. So we'll start. So the last time that we talked about in our physical pharmacy, just to bring you back sa kasatanan-tanan yung nga bakasyon, di ba? So we've had already the states of matter from the coarse dispersion or the different dispersed system. Amo pa man itong natakol ta. Actually, do kalawig-lawig na. But there are many inclusions in your dispersed system. So it's quite a bummer to not really have experiments on those coarse dispersion and colloids. I've had prepared some of the activities before tani, but nag-college week, nag-holy week, so doka, diba, datamaan naman kadamo gyapon sang doka saturated katama sang students, because I do know that some of your teachers will be gani compensating, diba, for the time. So many of the teachers will be giving also activities. But what I do want is just for you to really digest the theories and the topics. Okay, so good na na. So we will start anew with your finals with this topic, which is your ionic equilibrium. So it's basically, again, the general concepts of your acids and bases. So there's nothing special to it because you've already had it on your chemistry class. So again, we've had this, we have this different concepts for your acids and bases. So for review, who wants to answer? What is the main concept behind Arrhenius concept when we talk about acids and bases? So anyone? Para do ma-warm up ka da? So Arrhenius concept, what are we talking about here? So isa lang gid guys, ano ni siya nga element ang permita ginastoryahan? Anyone? Anyone? Hindi gusto ma-answer?
Hydrogen.
Okay, very good. So when we talk about Arrhenius concept, we are always talking about the movement of your hydrogen, okay, the H plus, or basically the proton present in your acid, diba? So, or the whole equation. So it's either, if you are an acid, what do? You donate some of your hydrogen to your base. Okay? So on the other hand, if the base is in an equation together with your acid, what happens? The base is the one that accepts your hydrogen. So we're already familiar with that. So this is an overview. So your Arrhenius concept is quite limited because compared to your Bronsted and Lowry theory or concept, ano din ang ginastoryahan ta? So si Arrhenius concept, it works if all of your acids and bases contain hydrogen. But miss, what if, di ba, doon nahambal ko ni before, what if miss, for example, si sodium fluoride, di ba, mga sodium fluoride ta na, mga ammonia siya, ila formula ya miss, hindi man na sila miss nga may letter H. So how will we know that this acts as an acid in my equation, di ba? So your Arrhenius concept is quite limited, but it's still valid if your acid and bases only has hydrogen. So with your Bronsted and Lowry concept, this is the one that backs up your Arrhenius concept, into which Bronsted and Lowry concept explains that there is proton giving and proton acceptance. So it's still the same to your Arrhenius concept. It's just that generalize siya ang hydrogen. So it means that even though it's not hydrogen, as long as it is positively charged, usually it is the one that is being given or being accepted by an acid or a base. Diba? So mula man na siya, guys. And next, we have your Lewis concept. So si Lewis we are using this to draw your Lewis structure. So usually, di ba, mag-draw ta mga Lewis structure, amo ni siya ang mga ginagamit ang electrons, di ba? So we are making use of the electron configuration of certain elements. Okay, so basically, your Lewis concept is all about electron transferring and acceptance also. So please search, okay, for this different concept. So butang ta na lang na sa activity nyo Kamo na lang fill up sang table kung sinong ga-accept, kung sinong ga-give proton, di ba? So on and so forth. Next, we will have your, muna na siya tanan guys, pinang wakal ko, bago lang. So, you can see, it's just the transferring, kung sinong base, and okay lang man guys, no, kung amhon ko ni, dasigon lang, kahit syempre, we've had this already. Because we will have a more important topic at the end of this class. So, we have also, amo man tong habal ko, so kamo na bahala basa. So, amo man ni siya gapon guys. Bronsted, conjugate. Okay, so we'll go with this one. So with all of those series that we've used, okay, so you learned already the 3 concepts. So in a certain solution or in a certain reaction, basically the neutralization, diba? So if you have an acid or if you have water, for example, and then you added ammonia to it, what happens? Of course, the acid here, ano ganing himuon niya? It will donate some of its hydrogen if we are going to follow your Arrhenius concept, or if we are going to follow your Bronsted-Lowry theory. What happens? Since your water is the one acting as your acid, it's the one that's going to donate some of its hydrogen to your base, which is your ammonia, and then it will become into a ammonium ion. So anong matabo? So si ammonia mo, which is the base before, becomes now the acid, diba? So on the other hand, the base here, which is your ammonia, simple ammonia na siya. Siya ang nag-accept na naman sang hydrogen. It will become NH4. And I mean your acid, which is your water before, lacks some of its H, and then it becomes your OH. So therefore, the acid here being produced becomes a conjugate of this base on the other side of your equation. So this is just your conjugate acid-base pair, because a certain acid becomes basic or becomes a base on the product side if there is neutralization process or there is movement of your protons and hydrogen. So hands up dabi kung gets naman ang ginanamin ko. Gets lang? Basta yung iba nalipat na. Okay, so very good. So many raise their hands. So goods na to that. Next, we have also your base. So basically, it gained some of the hydrogen and proton. So what happens? Of course, it will become acid on the other side. So this pair now is what we call your conjugate acid base pair man yapon. So guys, usually a certain product in here is just the plain acid and base. And usually the term conjugate acid, conjugate base, it refers to your salt. Okay, so it will come in handy when we go to your buffer equation. So medyo wala pa ako sa wisyo kung maghambal English, di ba? Do kaaga pa sang banwa. So next, we'll move on. So let's say for example here. Okay, so guys, anyone, who is your base here and who is your acid? So anyone, volunteer da nga mag-answer. Miss, si ammoning acid, si H2O ang amona. The moment that the other one gained this and that, this is what happened. So anyone, sino gusto ma-answer para may brain teaser kada aga pa? O diba, bongga? Anyone? Anyone? Wait, pa ka mo that, guys. Manglawag ko guro ay. Charot. I know that you're quite shy and it's still early in the morning. Sorry na lang. So, who is our acid in this example? So, as you can see, there is water again and your HF. So, when we talk about the HF, so basically, since it has the proton and your water is amphoteric, it means that it contains both the positive and negative charge. It could act as an acid and base at the same time. Therefore, your HF here will act as your acid. So, sa aton yung concept here, anong matabo? Since you already know that acid donates its proton or donates its hydrogen on the structure, therefore, anong matabo? HF rin naman ang aking beautiful. Okay. The HF now will be losing its hydrogen to your water, and your water will become a hydronium ion. So what happens to your HF is that it will just become an F, diba? So as you can see, this is the acid here, and its conjugate base pair will become your will become a fluorine lang ion. On the other hand, the base here, which is your water, gains your hydrogen, and then what happens? It becomes now your conjugate acid. So this area here, guys, is your salt, or what we call your ionized area. Okay, the ionized species. Okay, para hindi ta ma-confuse ka nun maglabot sa buffer. So this area is still your unionized. Sorry, gid sa chorus. Ano na naman ang akong pen. So I think we're good with this. Goods na ta sa amo ni nga concept. So next, we'll move on. We have your Lewis concept. So again, this is your movement of electrons. So ano gani guys? I think you've learned this from me before sa biochemistry. Ano gani? That's your Leora. Okay, para brush up na lang yung isang topics. And your G-Ro-Wa. So what do we mean by this? Si Lewis concept it works with this whole acronym. So once kabalo ka nga acronym, safe ka na. So it means that you lose electron via oxidation, via the facilitation, or with the help of a reducing agent. Okay, so again, your reducing agent is the one catalyzing your oxidation. Okay, and during oxidation, what happens is that there is loss of electron. So next, we have also Geroa, which is you gain electrons during reduction, and is facilitated by your oxidizing agent. So that's what it means. So as you can see, a Lewis acid here and a Lewis base. So si Lewis acid taya, it's quite opposite to the Bronsted in hindi ko bala kahambal mayo guys. Doon napitla ka sa mga. So your Lewis acid and Lewis base, they're opposite to that of your Arrhenius acid and Bronsted acid because anong gakatabo ya sa ilang nga concept, didto ya si acid ang taga-donate. So it's the one being selfless, or it's the one being generous enough to give its proton and hydrogen specifically. But in our Lewis concept, it's the one accepting the electrons. So if it is the one gaining your electrons, your Lewis acid is safe to say that this acts usually as your oxidizing agent. Okay? So, intindihanay? So, electron pair acceptor kuno si Lewis acid. So, usually, it is facilitated by an oxidizing agent. So, usually, it could act as your oxidizing agent. And on the other hand, with your Lewis base pair, it's the one donating some of their electron. And kung ga-donate ka, syempre, of course, you lose some of your electron. So, therefore, you are a reducing agent. So, amo naman na siya. So, Leora and Jeroa. So, I hope it's clear with everyone. So, ari, muna ni siya. Tanan na siya ng mga explanation. So, kaya nyo na siya ibasahon. Next, we'll move on with your degree of ionization and degree of dissociation. So, it's still familiar with all of you. So, again, you are going to be called a strong base or acid if you give out more of your H or your hydrogen. Guys, ano ganihaba ko before? If, for example, HCl. Is HCl considered a strong acid or not? So, kung those who agrees that HCl is a strong acid, raise hands, be. Raise hand. Okay, very good. So many of you raised hand. So actually your HCl is a strong acid nga. Okay? So because HCl is a strong acid because it gives out almost everything or almost all of its proton. So it's not necessarily nga kay tungod niya, miss, isa lang man ang iya H, hindi siya isog eh. So it's not like that. It's all about the ionization of the certain acid or certain compound in order for you to conclude that this kind of acid or base is strong enough. So for example, we also have what we call your CH3COOH or your acetic acid. So who agrees that your acetic acid is a strong acid? Anyone? Raise hand kung ga-agree ka nga si acetic acid kusog. Okay. So based on your reactions, wala masyado may nag-hands up because of course your acetic acid is a popular example of a weak acid. Nga man miss, nga wala ka unfair si CH3 na ginasa damo-damo na ginasa hydrogen, 'di ba? So may tatlo sa kabilog miss tinga why is it that it's not considered as a strong acid? Of course, because guys, usually your acetic acid dissociates only one of its proton. So mas kindamo ko ya proton, di ko maghatag. I will not give it my all. I'll just give an H. Okay na guys, okay na siyang H ko nga i-donate sa aton nga reaction akay para mag neutralize aton nga solution. Okay? So, di ba, HCl, ginhatag iya tanan, maski nag-iisa na lang, it's still considered strong because you will have a fully ionized species. So, there, when I mean fully ionized species, si H mo kag si Cl mismo dissociate completely. So, they will just go on their own ways, di ba, applying certain mga properties sa aton solution. Therefore, it is strong. Since guys, nga ginbuya mo or ginguba mong bond between H and your Cl, they are readily reactive to certain compounds. So for amo na gani guys, we never carelessly mix this strong acid and strong bases to just water or any kinds of solution. Kay amo ni siya ang ginahambalta nga may risk nga mag-explode. Okay? Because their bonds are really exposed and they are readily reactive. Unlike ya kay kay acetic acid mo, anong matabo, donate lang siya, mahimo lang siya CH2COOH. Chill lang kuya, bayin na lang yung iban. Ako ya basta intact ko diya. Okay, nag-donate lang tato yung jutay nga H in order for us to neutralize a certain solution. So safe saya because ang mga bonding niya hindi pa mo nagyapon ka-expose and it's not readily reactive. Gets lang? Goods na ta? Okay, we'll move on. So we have this different terms, the ionization and dissociation. So you are familiar with ionization already since this is used sa aton tubulang mga electrolytes to guys. When we talk about ionization, this is just the dissociation of your different or a compound that has no charge. So the moment that you put them in a solution or put them in aqueous nga solution, anong matabo? There will be separation of those different elements in a compound. And the separation of those elements from a neutral compound, they gain certain charges. So they become a positive, a proton, or an anion. A proton, a cation, or an anion. So it means that your ionization is just the action of your certain compounds when they are put into water or any kind of solvent into which they could dissociate. So, ang term ng dissociation, this is associated to your ionization because your dissociation is the one that would catalyze the ionization. So, kung hindi ka mag-dissociate, kung hindi mo gusto, kung hindi ka mag-separate, kung hindi ka magbuya sa isa ka bagay, you will never gain charge or you will never gain power, diba? So, again, life lesson 101. So, I hope this is clear. Okay? So, muna ni siya guys, aka muna na bahala. So, these are all the difference between ionization and your dissociation. So, mula man to. And we have also what we call the degree of ionization and degree of dissociation. So, usually, we are... Ay, way ko na butang. So, when we talk about degree of dissociation, this would be your... Sorry. Nga ako niya, ano naman, na akong pen. Wait lang yun, guys. For a while. Kiyari na siya. Okay. So, when we talk about degree of dissociation, guys, I think we've had this more deeper sa atong biochem, but no need na lang sa PISPAR. Importante sa PISPAR kabalo ka mag-solve. So, degree of dissociation, this is represented usually by your Ka. So, I think some of you had a hard time understanding this concept, your pH and your pKa. So, your Ka, guys, is your degree of dissociation. So, of course, since this is the degree of dissociation, the higher the amount or the higher the Ka value, of course, the higher man nga ga-dissociate ang ako niya compounds na ginabutang sa aqueous solution in order for them to become ionized. So, the more nga taas ang akong Ka, the more nga mataas akong dissociation, the more that I will become more ionized. Amo lang man na siya. So, the opposite of your Ka, so usually guys, si Ka is a really small number. I think that's 10 to the negative 7. So, your Ka is really a small number. So, therefore, we use pKa to express it. So, your P is your power or your negative log, I mean, in order for this to be converted to 7. Diba? So, usually guys, your pKa and Ka relationship are inverse. So they are the same concept, but it's just with the expression of a certain value in in order for you to write it simply, diba? Kung ako guro, kung ako scientist, ang Ka may mga 10 to negative, diba? Kasabad. So usually we use the pKa in order for you to just write whole numbers. So again, the higher the Ka, the higher the dissociation, the higher the ionization. On the other hand, the higher the pKa, of course, the lower the degree of your dissociation, the lower the degree of ionization. Because gani, opposite sila. It's just the way, it's just that we expressed your Ka into pKa in order for you to write in whole number. So do you get this topic or do you get this topic? Raise hands, please. Para maka-move on na ta. Do lecture ta pala ni ko nga part. So para chill ta karon sa lab dapat guys. Bira-bira ta sang isotonicity. So I myself medyo nabudlayan mo ko sa amo ni nga topic sa aton isotonicity. Next, we have your pH. Of course, when we talk about acid and bases, pero may tagid nga ginakadtuan would be the pH. I think everyone's familiar with pH derivation. No need na to discuss really further. So, already tanan sa notes, guys. No problem. So, your pH is just your negative log H. So, this is the power of your hydrogen. So, the more nga damo ka hydrogen, the more nga acidic ka. The more nga lower imo nga hydrogen, the more nga hindi ka acidic. But, again, this is pH. Si hydrogen or the power of your hydrogen is still, again, yung mga 10 to the negative something na naman. So, we've had already discussed this sa aton yung mga previous nga mga previous subjects before. But the most important is just for you to memorize this formula. When you have this, there's nothing to worry about. So this is just for your pH. What if, miss, POH ang gusto ko kwaon? Therefore, kung atong ginasturyahan guys, ano gani kung OH, this is basic. So miss, kung OH ang gusto ko kwaon, of course, you just put the OH concentration. And usually, this is in molars. Okay, this is in your molars. So guys, pH and POH, this is how it looks like to derive. But miss, what if? What if gidya be miss kung gusto ko magkwa POH, gingaan lang ko OH value. Gingaan lang ko OH concentration, but I do want to get the pH. What should you do? Of course, you just have to derive your formula into which you're going to have this different mga ambot lang kumiyari ko di. Okay, ali. So, if you are given with the OH and you want to get the pH, you just substitute this to the whole formula here. So, as you can see, kadamo ga chat sa mga requirements sa school. Okay, so, for example, you're just given with the OH. Of course, you just substitute it with this formula. And once you get the POH, to derive the pH, you just maneuver this formula, which is pH is equal to, it will become 14 minus POH. Okay, so it will become like that. So I guess it's quite basic. So gorabel sa ta sa other topic. So gets lang POH guys, kag pH. So hatag lang ta activity sa amo ni para do drills lang to just review the concept. Next, we have your buffer. When we talk, what is a buffer, guys? Anyone? Anyone? What is a buffer? Buffer. So your buffer is a solution that contains usually a weak acid and its conjugate base pair or salt. Okay? So, legally conjugate base pair, your conjugate acid or your salt. Or on the other hand, it could be a weak base and its conjugate base, okay, and its salt. So, kumbaga, if I have acetic acid in a certain solution, I will also have the sodium acetate. Okay? So, sa aton buffer, tawag siya guys buffer because they are solutions that are made to resist the change in your pH. So nga amis gina-resist niya ang change sa pH. It's because it has the acid and its salt form. What happens? May ionized ka nga area kag unionized. So the moment that you will add certain proton sa aton nga equation or sa aton nga solution, what happens? It's either i-capture lang sa sang unionized form para himuon siya ionized. So there will be no balance of this ionized and unionized nga mga species. So may duwa ka compound sa imo buffer solution. It can either be a weak acid and its salt counterpart, It could be a weak base and its salt counterpart. So guys, usually your buffer, we are just using your weak acid and weak bases. Nga anyone? Miss nga weak lang ginagamit ta. So anyone who wants to reason out nga miss nga mo lang ginagamit ta nga way ta dagaw sa HCl kag kung ano-ano pa da. Anyone? Anyone? Why gida? Okay. So of course, guys, you're just using again your weak acid and weak bases because ano to hambal ko gadiina kay kung strong ka nga acid, you are mostly reactive. Exposed halos tanan mga bonds, tamaan ka ka-ionize. So the moment that you come in contact with certain solutions, you change pH or there will be now explosion or a severe chemical reaction. As opposed to your weak acid and weak bases, they just give a little bit of themselves and there is balance on the conversion of their acidity to its conjugate base from being a base to conjugate acid. Minimal lang ang changes ta. Okay? So ari na siyang bilog tanga definition. So a weak acid and its salt or its conjugate base, a weak base and its salt or what we call your conjugate acid. So duwagi na kabilo guys ang ara sa unod sang aton nga buffer. And I think you do already know about this in your biochem, but in our body we have naturally buffers kay parang aton lawas kay di ba kadamo sa aton everyday mag-inom coke, everyday kung ano-ano pa nga mga oxidant ang gina-expose sa aton lawas. So therefore, there will be changes in our basicity and acidity sa aton lawas. So as a human being, ano ganing kinahanglan nga dugo lang or the acidity in our blood. So I think that would be 7.42 mga dira-dira. So 7.3 to 7.4 dapat dira-dira lang aton acidity. So ang body ta, they have an acid and a base area kay para to resist these changes in pH. So amo ni siyang purpose sa aton buffers. Also, the purpose of your buffers is for pharmaceutical solutions into which, of course, gin-store mo da siya for a long time. So, for example, may penicillin ko. Si penicillin ko, tamaan gini siya ka sensitive being a drug, for example. So, jutay lang add or jutay lang expose sa atmosphere, what happens? It becomes really acidic. So what you should do is to dilute it or the buffer that you would put your penicillin to should be suitable enough para mangin vehicle. Kaya para si penicillin, kung mag-expose gid man siya sa atmosphere ng matabo, hindi magtaas katama or magnubo katama ang iya nga pH. So here, we have the different buffer equations. So again guys, this is popular sa board exam and hindi ko gid malimtan sa module 5. Spelling guys. Guys, spelling. Dumabuang ko. As in, kung ano to ganing Hasselbalch double S or ang Henderson double S. So as early as now, memorize the spelling and of course the formula. So sa ako niya timingan lang to sa module 5 ko. What is the other name for the buffer equation? So ako ginatulo ko pa. Shit, parehas lang gid tanan. Ang spelling lang gid ang yawan ko. Double S to, isa ka S. So sobra ko guro bala katulok sang spelling nga ini. Doon nakita ko, doon mo na lang ako na dumduman. Jutay na lang gid ya. Kuan man, double S to, isa ka S. Imagine dra ka pamarong no sa spelling do ka sa luganon. So let's move on. So for a weak acid and its salt, okay, so I think you already have this formula before. pH is equal to pKa plus lagsa, diba? And you also have your pH is equal to pKa plus log Bs. Okay, so we also have other formula for your weak base. For example, miss, wala kaya biging tagaan pKa kag base ang ginastoryahan ta. So of course, you will just have the formula. pH is equal to pKw minus pKb that has been given to you plus log B over S. So hapos lang guys na? Okay. So we have two equations for this. You could use this one if you are given directly the pKa, but you could also use this one if you're just given with your pKb. And your pKw value, guys, is 14. So this is quite constant. So that will become 14 minus pKb plus log Bs. So with your examples here, I guess it's not really great because your buffer equations are just easy to maneuver nga, guys, because they are just merely substitution. Ang importante lang is you have to know sino akong salt, sino akong acid. And as you can see in the problem number 1, what is the pH of buffer solution containing 0.1 acetic acid and 0.1 molar of your sodium acetate? It's quite obvious in here kung sino ang acid kag sino ang aton salt. So basing on this formula here, anong mga kinahanglan ta? So pH is equal to your pKa. So you are only given, guys, ano gani? Ka for the acetic acid. So what you should do is to, of course, convert first the Ka into pKa. So pila, guys? So that would be negative log 1.75 times 10 raised to negative 5. So that would be 4.75. Guys, gin-convert ko siya into pKa. So the value is 4.75. So that would be 4.75 plus log over ano gani? S over A, the salt, which is the sodium acetate, 0.1 m over 0.1 m. Sodium acetate. And your acetic acid. So please, input sa inyo calculator. Pila answer, guys? Pilang pH ta? 4.75 plus log 0.1 over 0.1. Anyone? Pila answer nyo, guys? What's your answer? Wala gida. Anyone? Nag-input sa inyong calculator. Okay. So the pH, guys, would still be 4.75. Because, ano gani, guys? Log 1, kay 0.1 divided by 0.1 is equal to 0. Okay? So your pH is 4.75. Therefore, we could conclude that the certain buffer solution is acidic or basic? This is acidic. And guys, sa diri pa lang nga daan, you could see the relationship between pH and pKa. So with this one, ano gani, guys? pH ko, subong, ang value ko gid ha, is 4.75, and the pKa that we've derived earlier is equal to 4.75 also. So it means that at same concentrations of your acid or of your acid and your salt, as you can see, duwa sila 0.1 kag 0.1. It means that 50% is ionized in my buffer solution and 50% is also unionized. So I think doon nagabalalik ang tanan nyo nga memory sa amo ni nga part. So when we talk about pH in relation to your pKa, when your pH is equal to your pKa, it means that there is equal amount of species in your buffer solution. There is equal amount of your acid and its conjugate base. It means nga balance lang ang ara nga mga species sa aton. So makita mo mismo sa formula, no? pH is equal to 4.75 plus 0 because this log mismo, log 0.1 over log 0.1 is your plus 0. So pH ko at the same time is 4.75. Kung i-equate ko siya sa pKa alone, that would still be 4.75. So it means na kung si log ko, any kind, guys, ha? So for example, hindi niya siya acetic acid kag sodium acetate, tapos 0.2 molar siya kag 0.2 molar. Still, kung i-log ko ni siya over and over, this would still be 0. So the amount of my pH is always equal to my pKa. So it means na kung may parehas ko concentration sang both ko nga species, I will always conclude that there is both equal amount of my ionized and my unionized form. Sinong ionized form today? This is acetic acid. The ionized form would be your sodium acetate because this is now your salt or your conjugate base. Do we get this? Do you get what I mean with this one? Raise hands, guys. Raise hands, raise hands. Wala mi nag-raise. So medyo complicated ang topic. So when we talk about, we're just talking about the relationship ng pH kag pKa mo. So wala ya guys problema when it comes to substitution. O bisan nakuha ko na ng pH na amo ko ni. But with this kind of formula, you're able to see the relationship lang sa imo pH kag pKa. So it means nga kung kakita ka sa problema balagay sa board exam, nakalawig-lawig, ano naman? Lantawon mo lang ang concentration, anay. Kung kita mo nga parehas, it means nga hindi ka na mag-solve sang pH. Pagkita mo pa lang sang values ang pKa mo, amo na na siyang answer. Okay? Because at same concentration or at when your pH and your pKa is equal, it means that there is both the same concentration of the ionized and unionized form. So it means that there would be 50%, ang half mismo sa buffer mo da acid na da tanan, ang half na da basic. So this is a really good buffer solution since there is equal amount of your acid and your base. So the moment nga ma-add ko more acid sa akong buffer solution sa dre sa number 1, ano matabo? Salon siya sang akon niya salt. Okay, so sige, kadto ka di sa akon kay may capacity pa ko mag-handle more, kay 50% pa man lang. So the moment na mag-exceed ka sa certain nga threshold, that's the time that there will be now change in your pH. So that would be another story na naman. So with your problem number 2, so guys, di lang ka mo ni ma-confuse sa diri ang ginanamin ko di ang mga anyo na bala. Mga concept nito bala sa una sa biochem nga pKa is equal to pH. How about if pKa is less than 1? What if your pKa is more than 2? What happens? May 80% ba lang ionized? May 50% ba lang ionized? So on and so forth. So I think biochem gini siya and sa kinetics nyo ginabalik-balik na siya. Pero ang pinaka-importante is whenever pKa is equal to your pH, it means that there is 50-50 nga species present in that. So Draya gets na guys. Raise hands be. Raise hands. Or pKa plus 2 be. For example, plus 2, plus 1. So what does it indicate? May mas damo ko ba lang acid or mas may damo ko nga salt? Okay. So very good. Binag-raise hands na. So for the second problem, lasig sa oras. For the second problem, this is just again substitution. So as you can see, you're given with a Kb. So what we are going, an ephedrine guys is kind of basic. So don't worry kasi sa problem gina-indicate kung base na ni siya or acid ang atong ginastoryahan. So in here, pH is equal to 14 minus in negative log Kb mo na lang di guys 2.3 times 10 to the negative 5 plus log Bs. Sino aton base, guys? Here, our base would be your ephedrine 0.1 molar. Ephedrine. And the one containing your HCl is its conjugate acid. So this will become 0.01 m. So please, kamo na lang sa balay nyo da calculate kung pilagid man yung answer. But this is how you substitute it to your whole formula. Okay? So we'll move on. So lastly, the concept that you will be using gid perme, or ambot lang yun na pamangkot siya perme sa mga mock boards, would be the buffer capacity. So your buffer capacity, again, so is the quantity of strong acid or base that must be added to change the pH of 1 liter buffer solution by 1 pH unit. So with this one, your buffer capacity, ano gid bala kadamo nga acid, nga strong acid or strong base ang kaya ko i-add sa ako niya buffer solution, di ba? Take note, weak acid to yung weak base lang ang ara. So ano kadamo ang i-add ko nga acid nga strong or acid nga or strong nga base para si buffer ko maguba ang pagka-buffer ya. 'Di ba? So, for example, sa number 1 tading example, previously. Hala, nag-log ako ng PPT. So, 4.75 to, di bang pH? So, if I add an acid or a strong acid, pilagin ni balang quantity sa strong acid nga i-add ko for me to adjust the pH from 4.75 nga buffer solution pH into 3.75. Diba? Do gets yung ginanamin ko? Paano ko ni siya i-lower? Pila, ano kadamo akon i-add? So, we are going to make use of that via our Vance-like equation. Okay, so this is your Vance-like equation. So, but guys, akin memorize ko man na siya pag board exam because ang impamangkot is whenever you want to get the amount of a certain strong acid, basta doon mo nang iya nga pag sa board exam, what kind of equation should you use? Or if you want to adjust the buffer solution pH by 1 unit, which of the following equations should you use? And guys, wala siya guys ngalan. As in, tsura lang gid sang equation tanan ang nakabutang. So, kung malipatan mo siya, kung sinuding H3O, kung naka-square to siya or stuff like that. So, it's quite frustrating. So, as early as now, again, memorize this one. So, as you can see, this is the formula, and you will have an example problem here. So, the example problem is not really a problem because, ano guys, hindi ka mabudlayan. Kaya hindi na pamangkot yan sa board exam is, ano ang tsura sa equation? What is the equation that we use to calculate buffer capacity? But base mamalasan kamo sa inyo batch kag gaan kamo problem. But no worries about the problem because it's again substitution. There's no really problem when it comes to pKa, pH, and other stuff because it's substitution. Unlike to your gas laws, unlike to your colligative properties, kay damo tatuya guys, constants. Kung malipat ka sang constant nga hagid, di ba? Mga R constant mo na bala. So, si ato niya mga pH gagamo niyo, no problem. You just substitute. Okay? So, I think we'll take a break. Mga 5 minutes. Okay? So, drink your water and we'll proceed with your isotonicity nga topic. So, this is the end, I guess, of the ionic equilibrium. And in this note, naghang din siya guys. May din siya uses of your buffer equation. So take a break for a while. Let's go back at 8:55. Okay, so